3, 2, 1. Let's rock. Hey everyone, we are finally back. I hope you have nice 5 minutes of our absence. So yeah, our next speaker is Tetiana, and she has some really fun story about her hat. Can you share it? About
it's duct taped.
Yeah,
it's custom made for special for Ruby community.
Here we go. Yeah, it's double duct tape because it's duct tape, duct. I don't know how to
duct
say
tape
it.
And, duct taped with duct tape.
Should we consider this to be ugly hat or it's funny hat? I don't know.
Yeah.
It's kind of controversial. Yeah, so I'm not stealing your time. You have 25 minutes for your talk. I'm leaving right now. I'm pretty sure a lot of people just are pausing in front of their screens all over the world. So let's start. I'm leaving.
Okay, so hello everybody. Sorry for my voice. It's not very healthy right now, but let's deep dive into Ruby and OpenGL showcase that I prepared for you. Wow. Okay, so I've assembled a small repository for you to check after this talk when maybe you want to draw something by yourself. So I have a few links, helpful links that will help you to do it at home. Install. It's very simple. We'll be doing very beginning on very low level stuff. So what you need is only need just this OpenGL bindings gem and GLFWE library, which is a basic, very simple handler for Windows and keyboard callbacks. So we have this, I've assembled template, which you can just reuse to create your own graphic, just draw something here. It's based on the sample from OpenGL binding library. So we basically load these libraries. Next, we have to set the callback for escape button, so we know when we can finish our program. Then we create a window, setting context there, and we enter in main loop, which is like a core of the program. So we are trying to redraw and repeat our drawing until we press escape button. So inside of this window, we're setting a frame buffer size in the same width and height as we have for the window, setting the viewport there. And because we are in three-dimensional space, we have to set up some projection, like a viewpoint, like what user will see from this dimensional image. And then we clear everything what we draw on the previous step, draw something, and swipe buffers. We are drawing into buffer, like in one we draw, next is presented, and we swipe them in a loop every time. So this is a template, very basic stuff, and let's just draw something here. So I've copied to the separate file, and let's just try to run it to see what is what. So it's run basically with the Ruby. Let's see what we have. Yeah, so we have this small window that we can resize, and when we press escape, you don't see it, but I press escape, it's closed. So let's just draw something here. Let me just change a bit the size of this window. Let's be a bit bigger. Okay, so what we want to draw. So we are right now on a very low level. So we don't use any game engines on any specific libraries. We just using only tools that OpenGL itself provides us. And it provides us not so many stuff. Basically, in OpenGL, you can draw what linear geometry can draw. So basically, some points or vertices, you can assemble 2 points into line, 3 points or 3 lines into triangle, squares, and you can't draw any curves, any circles, because it's complex figures, and because we are drawing some raster image, and we basically have to, like, in the end, GPU have to calculate every pixel and every color for this pixel. So, and we have to know every point of the figure, and on circles, on curves, it's not possible, and you have to do some approximation for it. So let's just start with a super simple. Let me just draw an axis for our dimensions. So the first one, we need to write our loop, not a loop, but our block. So it starts with GL begin function, and we need to pass something what we want to draw, GL lines. And it ends with GL end. And as we are writing it in Ruby, we don't actually need a lot of brackets here. So inside of this kind of a block, we want to draw some vertices or points. So there is a function for it, GL vertex, and we need to pass, it's like a group of functions, so we use the functions that accept 3 points, and they are with float, but as well we are writing something in Ruby and we kind of don't care about it. And we need to draw a line, we need 2 points. Next one will be for x coordinate. Let's see if it works or not. Yeah, it works, we have it. Let me just draw every other x here. So it will be for y, and it will be for z. And let's just see how is it work or not. And you see that we, like, because we are seeing in front of it, we don't see this third dimension. To see it, we actually can just quickly do one transformation. We can use a GL rotate and float rotate function that will be accepted some angle. And it will apply this angle to the axis that we want. So I want to rotate everything, but there is no variable angle, and we would use the method that get time, and we multiply it for something, I don't know. And so we get current time, we multiply it, and we apply this angle to every dimension to rotate our viewport. Sorry. Let me just cheat and if it works or not. Yeah, it works. Quickly fixed. So yeah, we have our rotating viewport, but it's not really. We don't understand what exactly is rotating. So I would like to apply some colors to it. So in OpenGL, if you want to set a color for vertices, or for any objects or any shapes that you are drawing, you have to set a function GL color. And I've, like, to speed up things, I've assembled a few kind of objects that have different colors. So this is just like calling for GL color function, which has arguments for RGB colors, and it actually could be like 4F, and will be accepting alpha channel for transparency, and we want to use it because. So we need to quickly require this library, not library, but file. Okay, so color red, color green, blue. Okay, so we'll have different axes and different colors. Yeah, you can see like this is X, Y, that they are rotating. And what will be interesting to see as well is that if we actually set the different colors for different vertices, for example, yellow, or purple. So you'll see right now that OpenGL will, when we check our image, it will recalculate the colors for every point between these vertices. So let's see how it looks in real life. At least on the X coordinate, you can see that part of it is yellow and part of it is red, and it's shaded. So it's really easy to make something different from these vertices because just like points. And if we pass there not lines argument but triangles, so it will be calculating vertices not by 2 but by 3 and use them to draw triangles. And you can see that this is not actually, we can't draw anything from it because it's just actually the same vertex, and we can draw only line from it. So let's see what we will have here. Yeah, you can see a triangle and you can see it shaded. So one of the vertices is purple, the other are blue. So, and you can see that it's shaded pretty nice. Okay, so let's just change it back to lines and maybe just remove this rotation for now. And let me just draw something more sophisticated. So as we start, like everyone, I hope I'm not alone that's stuck right now at home and not going to the sea. So I would propose to you to draw this sun umbrella. It's very simple because we can simplify it in just use very simple shapes. For leg and for handler, we can use the boxes, or like we can use it. We can draw it with squares. And for this part, we can simplify it and use some equations for cone and draw it into three-dimensional space. So for the let's start with the boxes because they are very easy to draw. So we have to know the position of these 8 points. And if we know the width and height and the center of our box, it's kind of very easy to calculate the position of all these points in for all 3 dimensions. So what we're going to do now, I've already done it. So let me just show you quickly this box class that I created. It's accept width and height and center coordinate. And we have this there, the calculation for every different vertex here. Not vertex, but position of the vertex. And then we using the same GL begin function to start drawing what is square or quads. And we need for every square, we need 4 vertices, and we have these, I don't know, 6 different squares, and when they assemble, they'll be looks as a like a real box. Let me just remove these colors if you want to color them on our own. So we need to include it first. Okay, so we want to draw box, and we want to have it this width and this height probably. And why it's so small? It's not because like our window is quite big one, but our width and height for our box is quite small because we are not using we are using not absolute coordinates but relative one, and it's everything from 0 to 1 to 2. So it's a really easy. It's very convenient when you draw something complex here. So we need to draw it, and we need to pass our center. Okay, let's see what happened. Yeah, because it's good. Yeah, you can see that it's rotating about f y coordinate, and it's blue. So let me just add some rotation, and I want to draw with some pale white, for example. And we need to draw another box for our leg. It will be much thinner, but it should be quite higher. And we place our center above it. Let's see what we got here. We have this, not beautiful, but something, and it's rotating. I guess it's nice. So and just get back to the last and more interesting part of it. So how we can actually draw this part of this umbrella if we are only allowed to use lines and triangles. So we'll use triangles for it. And if we see, like, look up front on this umbrella, you can see that if we know the length of our umbrella and angle of opening of it, we can actually, using a very simple formula, we can know this part, which is will be in terms of cone, it will be a base radius, and this one will be a generatrix. And when we know this radius, we can see above the umbrella, and by knowing how many parts of the umbrella we'll have, we can calculate the angle, this angle between two parts. We know this part, we know this base radius, and this how we can calculate all the points, these points on the on our base, and how this. So this has given us two coordinates for our triangles, and the third one will be this one, which is the apex, or like a highest point of our cone. So let's just not draw it, but see how it's done, because I will as well. I've done it before this talk just to speed up things. So we are basically getting our angle, length of the umbrella, highest point, and how many pieces do we want. And we have to, like, we accept an angle in degrees, but we have to change it to radians. Then we calculate all the points on the on our base, and then we're using triangles to draw it. And I've already just used some colors to make it pretty nice. Okay, let's require on library. I'm keeping calling library, but it's not. So wait. And for example, we have this angle, and will be, for example, 0.5, and highest point will be 0. I don't know, maybe 8 and 0, and so, and the last one we, or no, maybe 8 pieces do we want. Let's see. It's not drawn. Yeah, because we need to call draw. It's drawn, and I would like to point you on right now it looks a bit ugly as an ugly head, but ugly picture, and I can't do anything about it. I just want to show you one interesting stuff. So in OpenGL, we actually there is a rule: what is drawn last will be shown, and other parts, like our last figures, they are just like they are removed from rendering. To make it smoother and more nicer, there is a special application, special algorithms for it, but this is like a very basic stuff. So that's why it's a bit delusional right now. So let's just get back from it. Let me remove rotation just to make it a bit nicer. And I would like to show you another thing. So we are like, I've make a point about the angles of our cones that it could be different. So I would like to use this one to just like change the angle in our animation. So there is some commented pieces for it. Basically, we are setting minimum and maximum angle for our opening, and with some increment for it. And let me just remove this part and put it somewhere here. So basically, we are operating with an angle. We just make an increment or decrement it, and you'll see how the picture is redrawn on every step. So you see this, our umbrella is opening and closing every time. So last thing that I want to show you is what happens if we change the quantity of axes that we have for our umbrella. So right now it's 8, maybe let's just 16. You can see that it looks more smoother. And I'm sorry, I need to rotate it at transformation of rotation as well to make it you can see it better. So if I'll change, for example, even bigger, make it 116, so you'll see that umbrella looks more smoother and it looks more like a cone right now. And this is very important stuff. This is called actually triangulation. And triangulation, let me stop sharing because I don't need it right now. So triangulation is a very important process that's used for creating graphics, because as I said, we can't draw any complex figures, can't draw circles or spheres. So every time when you see some beautiful computer-generated graphics, make sure that it's like there's a lot of triangles inside of it, and it takes a lot of calculation power to calculate this picture. And when you play in the games and you see some like ugly zombie, or you like watch a movie and you see, for example, Iron Man, so you basically is watching a lot of tons and millions triangles. So this is a joy of drawing when you're using math and use a little like, very small points to draw something beautiful. So thank you for listening for it. I hope you enjoyed this talk. So let's just get back to some questions.
All right. Can you hear me?
Yep.
I was thinking that it's probably first time in the history of live coding session which went right. So let's give our applause to God of Live demos. And we have pretty much a lot of questions here. Ready for them? Yep. Great. So first question is, can you give some production examples where it's helpful to use with Ruby? What is the reason to dive into OpenGL with Ruby for you?
I guess there is no reason to use it in production. Like maybe if you want to like create some beautiful visualization, for example, like the ones that Anton show us. So maybe there is a reason for it. My main reason was that I really like drawing, and for me, like I like Ruby, and it was my I was supposed to be a game developer, but once I found out like about Ruby, and I really don't know about computer networks at this point of time, and I decided that I want to dive in. And all these years after, I was thinking about how I want to draw something, and for me, just like a really nice that you can apply this beautiful language and draw something. And believe me, using Ruby, it's much nicer when you just use C language for drawing something, because you can organize classes and just nice.
I actually noticed that you have a slide in your presentation where you draw this nice triangle explaining angle. Is it you drawing?
Yeah.
Great. Yeah, it was really nice. Okay. Yeah, let's go to the next one. It's about, can I render third-party parrot with Ruby and use it in my projects? Anton asking. Which parrot? I mean, like party parrot is a meme for sure. I guess. Yeah. Yes.
Yeah.
The answer should be yes.
Yeah. Sure. But you have to like calculate like this with some. You'll need to have some equations to calculate this movement, so you can know the position of the points in every time in the space.
That's why you need computer science degree, by the way, just to calculate the formula to spin parrot.
No, actually, you just need to you need, for example, some nephew who have some like a textbook for geometry.
Okay.
For 7th grade. So
makes sense. What exactly was ported from OpenGL to Ruby on your library? How much overhead is it adding? And overhead, by me saying overhead, it means memory and CPUs.
So this, I didn't create this this beautiful gem. It was created by some other nice people. I guess they're not one of them, but so. It's just basically like OpenGL. It's not a library. It's just like a API, and there's like for different operation system, different platforms. It's implemented differently. And I'm using Mac, so we have OpenGL on it, and Ruby just accept it's just like a layer in between to get access to all these functions. So overhead, how much overhead is to edit?
Yeah, I mean, is it like comparing to C OpenGL, right? How much extra you need to use Ruby?
I guess it's everything, because it was very super simple, but as more complex it is, it's needs some more computation powers. And if you want to just render some, if you want to use basic OpenGL to draw some games on the levels that we have right now, I guess you won't be able to do it, because you need a lot of you need very powerful machine to do it. So
okay.
So yeah, so Ruby it's more I would say correctly, it's takes more memory than C. So LC probably would be a bit faster. But if you want to just play with it, so it doesn't matter really.
Okay, yeah. Is it like CPU or GPU render it?
GPU.
Okay. For what is the best graph Ruby app you can see live somewhere in the market now?
Graph Ruby. Does it mean for graph?
I guess it means some graphical desktop application using some OpenGL or something. Probably.
I don't know. there are some very nice game engines written in Ruby. So like
Oh, really?
they're using So if you go to like to this gem repository, there is a samples library, and you can see very a lot of examples. They're using these game engines. They are like they're not very powerful, but
Okay.
you can't draw like The Last of Us in it, but still it's nice, and it's something different from what we are doing every day.
Some indie games, right?
Yeah.
Yeah. Last time I did use Ruby for some visualizations was my university, where I need to visualize TCP protocol, and they only accepted desktop because there was no internet connection like on the room. So like I have to create something visual. But it was some ugly game called Shoes, I guess.
Shoes is I know it's not ugly. It's so good. I really
No, yeah,
like
it's fine.
But
Like it was ugly to start this jam on some Windows XP machine, which was ancient. And, like you have to be really patient.
Yeah.
Okay, can you use this question as well? Can we use this graph tool to make something difficult? I mean, like probably like like in C# on OpenGLs. I mean, I guess can we use this gem, right, to make something really difficult, like game engines or something?
I guess if you want to use this particular gem to some really difficult like computational graphics, you'll need to like the first thing you need to have is actually a degree in computer science.
Okay.
But there is not like libraries above OpenGL. For example, there is a GLUT, GLUT, graph OpenGL utility kit. It's like it's a name, but unfortunately, I wasn't be able to run it on my machine. So that's why I have to like go down to this using GLFV library, which is basically create Windows, and it's all. So there are some libraries above OpenGL that they are actually doing part of the job for you, but it's dependent on the machine as well.
Okay. Can you connect your OpenGL with some admin part and I think by saying admin, it means like some web admin interface, and give user possibility to make it like change it itself. Can you actually transpile your library, using this library to WebGL, or is there no option for this?
WebGL is kind of a super similar standard to OpenGL as far as I know. So it's based. So yeah, I guess you could, but like, why to do it if you can just write something in WebGL?
I don't know. Who knows? Dennis is asking, have you seen this Hestus gem library working with Vulkan API for rendering? I guess it's alternative to OpenGL.
No, I didn't. But Vulkan API, it's kind of like what is, as far as I know, it's like a standard right now, because for OpenGL, it's not. It's kind of it's became deprecated from year to year. Right now we are on the fourth standard, but it's not. It doesn't use all the powers from GPU. So it's why it's like changed to Vulkan. And frankly, I didn't look into Vulkan API, and I bet it's a bit different from OpenGL. So it's kind of different things.
Okay. What about like making these drawings to be interactive? Like, can you rotate it with the mouse? Is it hard?
No, it's not. You can actually add more. I don't know about mouse, but definitely it's super easy to do it with keyboard. You just have to add more callbacks, and for example, if you press some button, it's like it will be rendered. It just loop. So if you do something on every iteration of the loop, you can change it every time. You can like do some animation, enter some callbacks from keyboard, so you can do it.
All right. So last question for today, for this session. Dragon Ruby, have you seen it?
Dragon Ruby.
It's as far as I know, it's some toolkit for game development on Ruby.
Probably, but
Okay.
like there are some of them, but my particular interest was to do something or a very basic level to see how it's like just to do something with equations.
Cool. So you need to choose your favorite question to give away RubyMine license. Since you were doing RubyMine on your wife coding, it definitely makes sense.
Let me just quickly check on it first.
Yeah, just go through the list. A lot of people here. A lot of questions, by the way.
Actually, I like the best the first one that we answered.
Some production questions.
Yeah.
Okay.
Because
Cool.
I really like stress that we like why I like Ruby, because like this language can be applied to so many different topics, and we mostly work talking about web development, about backend for it, and there is so much more that we can do.
That's true. Yeah, so thank you for your talk. You will be available in the speakers room after a break, because we are going to have like almost half an hour break right now. But during the break, you don't need to just go somewhere else. We have a lot of activities here. You can go and check our partner stands, play some games. Also, there is really fun random networking. You should go and check. It's like this chat roulette, but with more selected people. So yeah, just go make some friends. There is challenge going on the Twitter as well. RubyConfBY is official hashtag. So take your ugly head. You can triple duck your type your duck, and it will be even more fun. And yeah, and after the call, we have Daniel pre-recorded. After the break, we have Daniel who dig really deeply inside Ruby and will tell us how to add some metrics to your application and not spend too much resources on them. Thank you for having here, and see you on Speakers Room. Bye-bye.
Bye.
1, 2, 3, 4. Why is counting to 10?